Hi everyone, today, we are going to introduce you to the logistic function and the wonders it could do to predict trends in economics, chemistry, and epidemiology when it is customized correctly. The logistic function was introduced between 1838 and 1847 as a model of population growth by adjusting the exponential growth model. The exponential growth model predicts the population size in an environment with unlimited food and space. This model is usually unrealistic because restrictions in the environment may impose a limit on population growth. A more accurate model would predict that as the size of the population approaches the carrying capacity, K, of the environment, the relative growth rate decreases. This equation is the so-called logistic model. The model reflects the slowing rate of population growth by modulating the exponential growth function to have this factor that approaches zero as the population size, P, approaches the carrying capacity K. Now we are going to learn about how the logistic model can be fitted to a set of data. Here we have the actual US Census data through 1940, together with a fitted logistic curve. Above we have the classical logistic model. Our job is to estimate what parameters R and K would give a good fit for the census data. We can rewrite this function so that it becomes the proportional growth rate, or the ratio of dP over dt, to P as a linear function of P. Therefore, to estimate R and K, we have to calculate the slope dP over dt at every given census year t. Calculate the ratio of that slope to P itself, plot that ratio against P, and fit a line of the form y equals mx plus b to the plotted points. The slope m of the line must be minus r over k, and the vertical intercept, b, must be r. Moving into our main session for today. The first application in this video is economics. By looking at trends generated from models, businesses and organizations can implement effective policies that will help them perform better in the future. We can see here that there are many models adapted from the classical logistic function to capture the relative change rate according to P that is not linear. A group of Turkish scientists fed the level of national income per capita into an algorithm called GeoGebra, which then yielded the best approximation and determined the parameters K and L to graph each of the adapted models, as well as the goodness of fit measures for each model. By combining such criteria, Model 6 is the best predictor for all criteria because its error is smaller than others. In chemistry, a single chemical reaction is said to be autocatalytic if the reaction where a product itself acts as a catalyst for the reaction. It is the reaction that is used to make photographic processing of silver halide film/paper. An autocatalytic reaction can be expressed as A plus B, creating 2B, which continue to act as the catalyst for the reaction. The conversion is slow, initially due to the absence of a catalyst, and then increases at a steady rate as products are formed, which also act as a catalyst. The rate of reaction, again, slows down with the depletion of reactants. The graph for these equations is a logistic function. Next, we can look at the application of the logistic function in epidemiology. The logistic function is a good fit to model the spread of a disease because it can model both the initial exponential rise in the number of cases and the leveling off of the epidemic. A group of Saudi Arabia researchers used the particle swarm optimization algorithm to fit the data to different customized versions of the logistic function. Here, we have the curve for the classical logistic model. Here is the better fitted generalized logistic function with the new scaling growth rate, R, to capture where the maximum growth rate occurs. Lastly, we have the generalized Richards model, which includes all the features covered by the previous two models, and an exponent factor, alpha, used to capture the deviation of the symmetric S-shaped dynamics of the simple logistic model. We can see that the last model is the best model to predict disease trends. To sum up, the logistic function is an ideal model to apply in multidisciplinary subjects. It can be regarded as a practical modification of exponential growth. While the rate of exponential growth is unbounded, this is unachievable in some cases, such as population where an upper bound is usually present. The logistic function, a more practical model, will solve the problem rightly.